Okay, hi everybody. This is the part 2 for topic 6.3 from ESS. We finished up with this diagram showing that how the ozone that you find in the troposphere is produced. Now you don't need to know all the chemistry involved, but you should understand that in a hot car engine, nitrogen and oxygen, which is naturally found in the atmosphere, under really hot conditions will form the nitrogen dioxide, which is released into the air. And when sunlight hits it, nitrogen dioxide splits into nitric oxide and one oxygen atom, and that oxygen atom combines with an oxygen molecule, which is O2, to make tropospheric ozone. So, how are the particulates formed that we find in the atmosphere that are measured using the AQI indexes? They come from burning fossil fuels, coal, gasoline, diesel, and other fuels, and they burn incompletely. All these fossil fuels don't completely burn into nothingness, or chemicals and gases that you don't see, and water. They produce sometimes very small unburned particles. They're mostly carbon. We usually call it soot, or it's also called particulates, or it's sometimes called PM10, meaning particulates smaller than 10 micrometers in diameter. And they're dangerous because the human body's not built to filter them out. The filters that we have as humans are nose hairs and hairs or cilia that are in the top part of our lungs. And they just can't do the job to filter out particulates. So the particulates end up settling deep down in the lungs, and they cause asthma, chronic obstructive pulmonary disease, which is called COPD, and lung cancers. These particulates that come from burning fossil fuels are carcinogenic, which means that they're cancer-causing agents. Now, when you're in agricultural areas, the particulates will cover plant leaves, and so the plants aren't as exposed to the sunlight as since they're covered, and photosynthesis is a lot less effective. And so you end up with much lower crop yields, which means for large populations like in China and India, where it's very polluted, you're endangering the ability of the country to feed itself. Okay, so how do we form smog in urban areas? Most of us live on this planet in urban areas. So when we're burning fossil fuels in our vehicles and in factories, especially on warm, sunny days, we end up with petrochemical smog. Lots of different, very complex reactions, chemical reactions, occur in the atmosphere, and we're not going to get into all of that chemistry. But the end result is there's a lot of secondary pollutants, chemicals, that are formed, including VOCs, which are volatile organic compounds, PANs, which stands for peroxyl nitrates. You've got ozone, aldehydes, carbon monoxide, and the nitrous oxides, both of which we've talked about before. The VOCs end up chemically oxidizing, which means adding oxygen. to the nitrogen oxide, and you end up getting nitrogen dioxide. And this does not break down ozone. So you end up with a huge buildup of ozone at the ground level, and your smog forms. You don't have to know all the chemistry that's involved. Just realize that these primary and secondary pollutants react very, very strongly react in the atmosphere, usually with oxygen, to form the components of smog. As we said before, nitrogen oxide is brown in color, and so that's why when you have a smoggy city, and if you go back to the beginning of this lecture, you can see that the haze over all of those cities is brownish because there's a lot of nitrogen oxide in that haze, in that smog. You end up with the highest concentrations of smog in the afternoon. And that's because of the role of the sun in smog formation. All through the morning, as the temperatures rise, you end up with the smog being formed. And so you have the greatest concentration of smog haze over cities in the afternoon. Cities that are in low-lying areas, or like they're built into valleys, are really susceptible to smog formation because the surrounding hills and mountains don't let the wind blow off and blow away the smog and the haze, and so it just builds up. And cities that are like that are Denver, Los Angeles, Mexico City, Mumbai, Athens, Almaty, which is in Kazakhstan, Beijing, Tehran, Rio de Janeiro. These are cities where their topography, where they're surrounded by hills and mountains, and the city is set into a valley. They invite the buildup of smog, and the smog is not easily dissipated because the winds just can't get into that valley and blow the smog away and dissipate it. Okay, so this is a diagram how the petrochemical smog is formed, where you've got the sunlight reacting with the nitrogen dioxide. You've got the nitric acid formed along with oxygen, and it shows you how the ozone is formed, and that how nitrogen dioxide and nitric acid are reacting with aldehydes and PANs and forming the petrochemical smog. Like I said, you don't need to know all the chemical reactions, but an understanding of this diagram is very important. Okay, so we've talked a little bit about how weather affects smog. Wind will blow it away from the area temporarily. So as it's formed, as long as the city is not sitting in a valley where it makes it a little hard, the wind will blow it off. Rain will wash pollution out of the air temporarily, but it deposits it on the soil and the plants, and that creates another whole group of problems. Thermal inversions make petrochemical smog worse. So what happens is that air over the cities is usually pretty warm and the pollution just rises, okay? But thermal inversions are when a cold layer of air moves over the warm layer of air where there's a city, usually sitting in a valley. And this cold layer ends up holding the warm layer down because cold air wants to fall and warm air wants to rise, and they're not in the right spot for that to happen. So the cold air that wants to go down towards the land holds that warm, polluted layer of air close to the city, and you can't disperse that pollution away. That's why, another reason why cities that are in valleys, not only it's hard for the pollution to be blown away, but when the inversion layers come, usually in the winter, it just makes the pollution to be just horrible in those cities and very hard for on people's health. So here's a diagram of what normal conditions are, where you have the warm air. You have the you can have the dissipation of the smog, and then what the inversion looks like. Now, in rural areas, you also have pollution. It's not usually as evident, but forest fires and crop burning contribute to smog. And when it's blown over urban areas, it creates even more problems for those areas as far as pollution goes. This is one of the reasons also, besides a lot of vehicles and factories burning fossil fuels and coal being burned in people's homes. In the fall, crops would be burned, and the wind would blow all the fire smoke into the cities too, and it created in October just really horrible conditions between middle of October and the beginning of December, because farmers use crop burning. Really, it's a traditional method to remove the excess biomass from crop fields. When you've harvested the crop, there's the part of the plant that isn't taken, stalks from corn and various other biomass. And in developed countries, farmers can afford expensive implements and attachments to their tractors, where they can plow this biomass under the soil, and it's used really to fertilize the soil for the next year. But in areas like India, where the farmers are quite poor, it's a less developed country economically, the way to get the fields ready for the next year is to burn the crops off. And so they burn all this biomass off, and it creates just horrible pollution. Okay, this is the last slide. What do we do to manage our urban pollution? Well, first of all, we got to change human activity. Burn less fossil fuels, develop our alternative energy and fuel technologies, use more mass transportation, or even bicycle. We've got to regulate and tax polluters. We got to regulate fuel quality. Make sure that we're not getting fuel that's got a lot of sulfur in it and other potential pollutants. Make sure that cars have efficient catalytic converters and that they haven't been removed from vehicles. And we also need to green up the city so that carbon dioxide that we do produce can be absorbed. This is it for topic 6.3. Thank you very much.